What's good, my statisticians? This is Professor Sampson from PS I Love Math, back with another statistical banger. Last class we talked about measures of center. This class we'll be talking about measures of variation. So stick by, wait for me to share my screen. Today I'm filming my intro from Towson State University. So as I said, we're going to be covering section 3.2, measures of dispersion. Remember, we talked about center. Center had to do with where the data is centered on the line. And measures of dispersion or variation, all right, is the shape of your distribution. So this tells us the dispersion tells us the true variation of the data. What do we mean by true variation? Well, think of it like this. You can have two sets of data that have the same mean, but they could mean something totally different. What do I mean by that? For example, you can have something that's 10 and something that's 5. They have a degree of 5 separations, but so does something that's 50 and something that's 55. They both have the same degree of separation, but is one more important than the other? We'll figure that out. But that's why we need to know the true variation of the data and not just where it lies on the number line. It doesn't tell us a lot about what we're trying to find out. So let's go through these measures of dispersion, the important measures of dispersion. The first measure of dispersion, we call it the range, all right? And the range is just your max value minus your min value. So in your data, you have a maximum number and a minimum number. You take the two, you subtract the two, and then you get an answer. All right. It's not very descriptive. That's what that word is. I'm not about to erase it. It's not very descriptive. Why? Because it doesn't tell you anything. If you have outliers, then your range is really going to be off. But it's easy to use. That's why we use it. And it's easy to get the answer to. So let's go to our most common. The most common measures of center are variance and standard deviation. But these are the most common. And these tell you how far from the mean your data value is. Remember, the mean is what from last section? The mean is the average, if you want to use that word. We don't use that word in stat. But the mean is the average of your data points. So the variance and the standard deviation really tells you how far is this from the center? How far is this from C? How far is this from the middle? That's what the variance and standard deviation tells. So if you think about it like that, a large variance or standard deviation means that the data values are more spread apart, right? So a large variance or standard deviation means that the data values are more spread out. That makes sense, right? Think about it. If your mean is in the middle and your variance and standard deviation, right, goes out, all right? If you have more away from your mean, then your standard deviation and your variance is going to be larger because those numbers are going to be further away from the mean. Vice versa. If your standard deviation or variance is small, that means that your data points are closer to the mean. The variance and the standard deviation are related. The variance is the square of the standard deviation. It is a squared measure. Now hold on to that because you might not understand squared measure in a minute, but we can't really do anything with squared measures, okay? But the variance is the square of the standard deviation. So if you have a square, something squared, let's just say x squared. If you wanted to get x by itself, what would you have to do? How do you get this x squared by itself? You have to take the square root of it. Again, I'm not going to go through that math, but a square and a square root cancel each other out, leaving you with x. If something is squared and you want to get what that thing is back, you have to take the square root of it. Cube root, etc. So if you don't know that, how about you comment down below and let me know if you remember this. The question is, do you recall square and square root? Do you recall that old math? Comment down below and let me know, okay? But that's the opposite. The reason I had to tell you is that the population variance, and I'm going to say population, that's sigma, and it's sigma squared because the population standard deviation was this sigma sign. And remember, the variance is the standard deviation squared. So the formula for this is the sum total of whatever your data values are. We're going to call them x sub I because it could be a whole bunch of different data values, minus mu. Mu, you remember that from the last video, squared all over capital letter N. So capital letter N is the number of data values for the population. Time for the matrix again. Watch the screen. So that's the formula. We'll talk about the formula in a minute. But what I wanted to point to, the fact that the sample variance is standard deviation of a sample. So the sample variance, S squared, okay? That formula is going to be equal to, because we're talking about the sample, you still have your x's, but what are you going to subtract it from? The mean of the sample, which we talked about was x bar all over little n minus 1, as opposed to mu is the population mean. And lowercase n, all right, is the number of data values. And just so you can have all your letters in place, remember S squared is what? And you might want to stop and take a picture, take a commercial break. I don't have a commercial, or maybe I do. You'll be looking at it if I have one. But you might want to stop here and write down all these letters and write down all these definitions, because if you don't know these definitions, then you will not pass statistics. You have to know the symbols. Now, so at first we knew about them, but now they all have their own symbols. And you need to write the symbol equals the answer. In my classes, you have to write the symbol equals the answer. It's not enough to say, I got a mean, and I'm going to say which mean. How do I know which mean you're talking about? Are you talking about the population mean? Are you talking about the sample mean? All right. Hopefully you looked at the last one, but the rounding rule for variance is the same. So that means you have to know what it was, is the same as the rounding rule for the last section we talked about for measures of center. The next thing I'm going to do is, before I was going to have you guys do a problem with that, but then I'm going to give you the other definition, and then when we finish all the definitions, then we'll go in and do some examples. So grab some popcorn and everything, because we're going to be here for a while with these definitions. And while you grab popcorn, I'm gonna grab a matcha.
Just give it up. I'm not your girl and I never will be. Don't call me up. Don't waste your time, cause I'll be your enemy. If you want love, look somewhere else. Here you'll find nothing. Just give it up. I'm not your girl, cause I only love me. Don't get me wrong. You and I could have fun together when I feel done with having fun on my own. It's better to care for yourself, not rely on somebody else. So don't get me wrong, I'm just riding alone. Just walk away, cause I can always.
Thanks for helping me make my matcha. Don't forget to subscribe.
If you wanna.
We're back. Thank you for watching my matcha video. Anyway, so we're going to talk about standard deviation. All right. So let's go to standard deviation. So we just finished talking about variance. Now we're going to talk about standard deviation. So the standard deviation is a measure of how far we would expect a typical number or member of the data set to differ from the mean. It's how far, how much we might expect a typical member of the data set, or a number, if it's a numerical data set, to differ from the mean. Remember, the mean is the middle value, right? It's pretty much the average. That's what the mean is. The mean is average. So average is where we start. Think about grades. If you have a C, you're average. So if you're below a C, you're less than average. If you're above the C, you're more than average. But if you're at C, you're at the middle. So the question is, how far we might expect the typical data set number to differ from that mean. So if a class mean is 70 and you're an 80, how far do we expect to differ from that mean? You're 80, you could be a 60, so you're different from that mean. So the standard deviation tells us how far we may expect the typical member of the data set to differ from the mean. The standard deviation is it in this class. If you don't understand standard deviation, then bye-bye to statistics, because we will be talking about standard deviation from here until the cows come home. So now we're going to talk about the formula. Now we just said what the difference was, right, between the population variance, or between variance and standard deviation, right? So the variable for standard deviation for population standard deviation is what we had up here. It's just sigma. We're not going to square it. So it's the same formula, the square root, all right? And then, of course, the sample, now we actually will not even be using the formula by hand, because I'll show you in a minute why not, because the formula is just too long to expect you to do it by hand. Your three different measures of dispersion or measures of variation are range, variance, and standard deviation. Make sure you know the letters. You will not be allowed in my class to write standard deviation equals. You have to tell me which letter, obviously, because there are two standard deviations. There are two variances. So you have to tell me which one are you talking about. Are you talking about the population variance, or are you talking about the sample variance? Are you talking about the population standard deviation, or are you talking about the sample standard deviation? Are you talking about the population mean, or are you talking about the sample mean?
Oh my God!
Whew. Now, there's also something in a book called Coefficient of Variation. You can read on that. And in my class, we won't be covering coefficient of variance, but since this is for everybody, all my YouTube statisticians, if your instructor is covering coefficient of variation, and you want me to make a video on that, please comment down below. So let's move on. And later on, we still have to cover the empirical rule. So again, you need popcorn, you need chips, you need whatever you need, because this video is going to be for a while, because this is a teaching video and a learning video. So the good thing about this is, as I said, these are the formulas, but we won't ever use the formula. We won't be using these formulas. They are too time consuming, and that's the reason why you bought a $100 calculator. But that's why you bought a calculator. So the calculator does the work for you. The only thing that you're responsible for is giving back the information, and sometimes interpreting the information, and giving back the information with the proper rounding rules. That's all you're expected to do. So if you don't write the answer right with the proper rounding rule, it's incorrect. Why? Because you're not doing any other work. What work are you doing? Nothing. The calculator is doing the work. So I am going to go through really quick how you use these by hand, and that'll show you why we don't go through this by hand. So I'm just going to give us a few numbers. So here's an example. So let's say you were told to find the variance of this list of numbers. Now these numbers don't really mean nothing, meaning I didn't tell you where this data came from, what this data was for, or nothing like that. I just asked you to give me the variance. And we know the variance, right? And I'm going to say it's the population variance. I'm going to say the sample variance. I'm going to say this is a sample. So that takes care of that. So that's the formula we saw from up top talking about the variance. And what it actually means, just so you can see how it's done by hand, is you would take each one of these. You would find the mean of this data set. And I'm going to do that really quick. I'm not going to do it on the screen. Again, we're not going to be doing this. But X bar is 4. So the reason we don't do it by hand before, and some of you may be tasked to do it by hand, is that you would have to do each of these first. So your first column would be your x sub I minus x bar. And your second column would be x sub I minus x bar squared. 3 minus 4, which is equal to -1. Then you will have 2 minus 4 equal to -2, and so on. All right, and then your next column would be to square these. So -1 squared is 1, -2 squared is 4. So we did that. Now we need the sum of this. So the sum is 10. That's what this sigma means. Sigma is the sum. So now your s squared is equal to what? All over n. N is the number of data values. So in this case, n is equal to 5, right? Minus 1. And what's that equal to? So your variance is 2.5. So now can you imagine, this was only 5 data points and it took me a little while. Can you imagine consistently doing this over and over and over again? Tons of data values, more than 5. Having to do all these columns here, more than 5. Now, don't get me wrong. When I learned how to do this, I didn't have a fancy calculator, okay? I'm jealous. I'm jealous of the way. I'm jealous of the way. All right, so I'm jealous of the fact that you got to have a handy dandy fancy calculator, and I had to do this by hand. I'm going to do this problem right here in the calculator. Standard deviation, since we're calling this sample, is S, all right? And the standard deviation was what? It's the square root of all that stuff. So it's the square root of this stuff. Now we've done all the hefty work for this, so we know that we got 10 over 4. So you take the square root of 10 over 4, S equals 1 point. So let's do this in the calculator real quick. Let's go through, well, it won't be quick. We'll walk through this example since we already did it by hand. We'll walk through this example with our calculator and see that we get the same answer, or a similar answer, but see that we get the same answer with the calculator. That and edit, right? Go into our list. So we put in our number. Once we put in our numbers, we do what? We go back out to the front screen. We're going to go back to our one variable statistics. Remember, we saw that before when we was looking for what? The mean. Now, if you didn't watch the last video, in this video, I'm going to show you a trick for the median. Now, the top one is X bar. If we were looking for the mean of those numbers, that would be 4. The next thing, which we don't talk about, I'm just telling you what they were. You might remember that the sum of our digits was 20. That's sigma X. You see that up there, that the sum is 20. And then we go down. Now this S here, there's no such symbol, but this is just the symbol that the calculator uses. This S sub X, all right, that's the standard deviation of the sample. That's what you'll be looking at, unless the question specifically asks you the standard deviation of the population, which means you would use the one under it. You see the sigma. Please don't write S sub X on a paper. There's no such symbol. The symbol for standard deviation is S. The symbol for population standard deviation is sigma, all right? Not with that X. That little X is something the calculator does. A couple more things in here that you'll see. N equals 5, that's how many we put in it. And you see that MED, that's the median. So remember the last class when we found our, I didn't tell you that, when we found our X bar, we could have also seen our median in here, right? That's all we get from this. Okay, so you could have found your median right here in the calculator. So let's go back. So we're looking for the standard deviation. And as you see, the standard deviation, S of X, is 1.581138883. Now to return that answer back to me and get credit for it, you're going to use your rounding rules, which is one more decimal place than is listed in the data. And as we know, the data didn't have any decimal places. So 0 plus 1, that means we're going to have one decimal place. So our answer for S is going to be 1.6 because there's an 8 behind there. Come on, these are second grade rules. Anything 5 and above, you go up, and anything less than that, it stays the same. So this is going to be 1.6. So the question becomes, yeah, Professor Sampson, I got my calculator. Okay, where's the variance? It's not there. And I'm going to tell you something really important. So if you stop looking at the video at this point, you're jacked. So let's look at this. We said that it was 1.6. But the thing is, you put down S equals 1.6. That's the proper answer. So now you're looking for your variance. So you have here, and now you're looking for your sample variance. Now look what happens. You need to pay attention. Tell all the people in your group, tell your friends, tell your family. If you decide to say, well, I'm going to take 1.6 and square it because the variance is the standard deviation squared, and hopefully you know how to do a square, but square, okay? You're gonna get 2.56, which you would be rounding to what? 2.6. So some of my students will put S equals 2.6 and wonder how they got it wrong. Listen, Linda, listen, all right? Yes, you need to write 1.6 as your final rounded answer. The cardinal rule for statistics, and we will repeat it again, is that you always carry out all the decimal points. Let me say it again. The cardinal rule in statistics is that we carry out all the decimal points. That's the whole reason that you have this calculator, that you had to pay the money for the calculator. That's the whole reason why in real life statistics, we use programming and programs, because we need to carry out all of the decimal points. So even though in the classroom you have to round your answers so we all get the same answers, so we all know they're the same answers, you are usually carrying all of your decimal points. Why did I say that? Why did I need to say that? What was the big deal about it? If you look back here, your standard deviation was 1.581138883. That's what you need to square. So you can write that down, 1.581138883. Let's see if I can remember that. 1.5811383. If I square that, I got what? 2.5. That's my rewind sound. Remember, when I squared 1.6, what did I get? 2.6. So who has the right answer? Student that has 2.5 or the student that has 2.6? Definitely the student that has 2.5, because 2.5 is the answer you get from squaring the standard deviation with all of its numbers. 1.6 is the answer you put on your paper so that we can all get the same answer. I cannot stress that enough, and that's where students fail this part of the exam. Now, do you have to remember that 1.5811383 or keep writing it on your paper? No, there is a shortcut on how to get your calculator to round that number. You're going to hit the VARS button, V-A-R-S. It's next to the clear button in between the program button down from the up and down button. You're going to hit the VARS button. You're going to go to what? Pay attention. You don't have notes for this. You're going to go to what? Think about it. What class are you in? You're in statistics. So you're going to hit number 5 for statistics, right? And look, that's why you need to know the symbols. If you know the symbols, you know which symbol we're looking for. What symbol are we looking for? We're looking for the sample standard deviation because we need to square that to get the variance. So we're going to scroll down to number 3, or just hit number 3, because that is the sample standard deviation, right? Not the population, not the one down from it. We hit that, and then we're going to square. So when you square that, boom, you get 2.5. Look at there. That is the correct answer. 2.6 is wrong. So you didn't even have to memorize it. What you just did is you told the calculator, hey, can you go in and pull out the sample standard deviation from the last set of numbers that I put in L1, go get those from L1, and I need to square it to find my variance, which is what you did. I hope you get this with the rounding rule and everything, because this is why people fail the exam, because they can put the work into the calculator, but they expect the calculator to spit out the right answer, or they just copy out all the numbers because they don't want to think. Okay? We're going to think. We're in the statistics class. We're going to think. We're going to think like a statistician. That pretty much takes care of that one. So we're going to do 2 or 3 more examples. And again, this video is long, but I suggest you wait until the end and you practice each one of the ones that I'm practicing with you so you can get it down pat. If you don't get it down pat, then it's your grade, not mine, right? So we're going to get this down pat. It's been so long that I had to put on my specs to see. So take a second to take a picture of this problem. And you know I'm going to have some kind of commercial break while you take a picture of this problem. Okay, so now I have all the numbers in my calculator. And remember, the range is the highest minus the lowest. And yes, with these types of numbers, you can look through and figure out your highest and your lowest. I don't suggest you do that. What I suggest you do is you go to your calculator and you use what we did before by learning how to order our data. But once you have your data ordered, then you can see the highest and the lowest number. In this case, our highest and our lowest number, 21 and 13. So you're going to have 21 minus 13, and that's going to be your range. That's why knowing how to order them helps you out a lot. So our range is going to be our highest number, which is 21, minus our lowest number, which is 13, and that's going to be 8. That's our range. The next one is the population standard deviation. Population standard deviation. And then we have what? First, you got to say, okay, standard deviation, the population, what variable is that? What symbol is that? Well, that's going to be population standard deviation is sigma. So now you're looking for that. It's also asking you for the population variance, which you won't be writing down these words. You will simply be writing down the symbols and the answers appropriate. So the next thing they ask us for is the population standard deviation. What is the symbol for population standard deviation? Sigma. So we're going to go to our handy dandy calculator and pull up stat, calculate one variable statistics, L1, because that's where our data is. And we're going to pull this up. And where's the population standard deviation? The data had none, so you need 1. So the population standard deviation, this sigma here, is 2.4. We're going to take 2.4 and square it. Not if you want to get the answer right, all right? You're going to go to VARS. you're going to go to statistics, number 5, and this time you're going to hit 4 because that's where the sigma is. So you're going to hit number 4, you're going to square it, and then you're going to get the answer of 5.6875. But your answer is going to be what? 5.7. Your answer is 5.7. And check it out. If you took 2.4 and you squared it, you get 5.8. So you see they're off. Some of them are off by a hair, and some of them are off by a whole daggone bun like mine. Okay, so this one is off by a hair, but it's still off. The appropriate answer is 5.7. So those are your answers. It's pretty simple. So let's do our next example before we go to our final set of information. Again, this is a long video. It has a lot of meat in it, so that's why it's long. But this is a lecture video, so you're in a lecture class. So this is the next problem here. So take a picture and put these numbers in your calculator as I go and put them in my calculator. Now you'll see currently, since I don't reuse the numbers, I just constantly use list 1. There's nothing wrong with using list 2 if you wanted to, but I just keep using list 1 until I can't no more. Right until I can't no more.
Take my horse to the old town road. I'm gonna ride till I can't no more.
Find the range, but we're going to find the sample standard deviation and the sample variance. So the range is the lowest minus the highest, and your highest number is 3, your lowest number is 1.5. Of course, when you subtract those, you get 1.5. So now we're going to find our sample standard deviation. All right, so again, this should be fast. We're looking for our sample standard deviation, and our sample standard deviation is here. Don't make a mistake and use the other one. Now, decimal places did our data have? If you look back at your data, we had 1 decimal place. That's the highest number. Yes, 3 and 2 had none, but we had 1 decimal place. So because we had 1 decimal place, we need 2 in our answer. So our sample standard deviation is going to be 0.47. A lot of times I don't put the zeros in front. It's going to be 0.47. You need 2 decimal places. If you put 0.4 or 0.5 or any of those things on the test, it is wrong. 0.47. So you're going to put in 0.47, or some of you can put 0.47. I don't care. But if you put 0.47, you better make sure that you have those decimals there. And are we going to square 0.47? No, we're not going to square 0.47. We're going to go through the calculator and calculate our sample variance by going where we need to go. So that's going to be 0.22. So that's about it. So the important part about this stuff is that you're able to do what? Is that you're able to read your calculator and round appropriately. The rest of the work is being done by the calculator. And no one wants to do standard deviation or variance by hand. So the fact that you don't have to do it by hand in my class and in most instructors' class is a good thing, but you at least need to know how to round your answers when they come out of the calculator and not just write down anything you wanted to write down. Okay. All right. And just when you thought it was over and I was about to say, please make sure you comment, like, and subscribe to my channel. I'm at 212. I'm trying to get to 220. And why don't you be the last 8 people? So hopefully you don't click off this video, because I'm like those nighttime commercial, you know, that give you the extra one. But wait, there's more. All right, so there's more. What's more? The empirical rule, right? Yeah, that's in there too. I had to swap you with that. The empirical rule. So for all your friends who stopped listening, stopped watching, that stopped, dropped, and rolled, they rolled out of the rest of the lecture. Like I said, this is a long lecture. The empirical rule. Now you hear a little bit of my Jersey accent coming out. It's actually the empirical rule. Those are I's in the middle, but who cares? In my crooked letter, I, humpback. Okay, so what is the empirical rule? Now for my class, we're not going to do Chevy Chev's rule. We're not going to do Chevy Chev's rule. That's something else the people who missed the video or stopped the video don't remember, don't get. We don't do Chevy Chev's rule. They may do it in the system or in there. You just get through it because it's there, but I'm not going to test on it. But anyway, the empirical rule, what is that about? I'm going to knock it down to you really quick as I can, because I know this video is long. It's actually not long. It's a lecture video. This is not a How do you put sample standard deviation and how do you do this? Is not that kind of video. If you needed instruction on what was going on in your stat class, this is the one for you. And you can always like and subscribe to let me know this is the one for you. Anyway, so this is the empirical rule. The empirical rule is 68%, 95%, 99.7%. That's all you need to know. Thank you and God bless. Thank you for coming. No, anyway.
So thank you very much. We love you. God bless you.
So the empirical rule, right? It tells us how far this is used to estimate the percentage that values are within the standard deviation, within the mean, okay? So let's say if you had the mean, let's call this, and say we have our little number line here, right? So what the empirical rule does is say that stuff between -1 and 1, 68% of your data is going to fall between -1 and 1. What the heck does that mean? If there's a test, 68% of you are going to fall within this part of the grade. Okay? So 68% of the data is going to fall 1 standard deviation away from the mean. 1 hump away from the mean. Now, 95% of the data is going to fall within 2 standard deviations of the mean. So 95% of the data is going to fall within 2 standard deviations of the mean. And 99.7% of the data, so most of your data, is going to fall within 3 standard deviations from the mean. So that's the empirical rule. How far or how many standard deviations away from the mean will your data fall? How far away from the mean will your data fall? 1 standard deviation is 68%, 2 standard deviation is 95%, and 3 standard deviations is 99.7%. The empirical rule is best represented by an example because you know the numbers are 68, 95, 99.7. And the one thing that I forgot to mention, the most important thing is that this is only for bell-shaped data or symmetrical data. So when your data is bell-shaped, so you will see in your problems, it'll tell you that it's bell-shaped, because if it's not bell-shaped, meaning if it's skewed left or right, then this is all gone out the window. Now, Chevy Chev's rule, the one that we don't cover, is the one we use when the data is not bell-shaped. Suppose that private school tuition in one region of the country has a bell-shaped distribution. See, they have to tell you that it's bell-shaped. And then they tell you that the mean is 25,400 for that particular school. So that's the mean. And the standard deviation is 1,300. Now, remember, the standard deviation is, I would call them the humps, all right, like camel humps that we go out from the mean. So the standard deviation is 1,300. Approximately what percentage of tuition is between 24,100 and 26,700? So you got 25,400 and your standard deviation is 1,300. So let's do our little hump here to give us 1 standard deviation above and 1 standard deviation below. So if we take that 25,400 and we add 1,300, what's that equal to? Then we take our 25,400 and we subtract 1,300, what's that equal to? So for your answers, you may have to do it once if it's 68%. You may have to subtract it twice, which gives you 95%. You just have to go with the data. So 25,400 plus 1,300 is equal to what? 26,700 is when we added 1 standard deviation, 26,700. So we added 1 standard deviation and that got us to our 26,700. Now I'm not going to show it, but if we subtract, we're going to get to 24,100 if you subtract. So this is minus one standard deviation. So 1 standard deviation, so between here and here. So the question is approximately what percentage of tuition is between this and that? Approximately what? 1 standard deviation is what? 68%. Let's do another one that may not be as straightforward. Suppose that electric bills for the month of May in one city has a bell-shaped curve distribution. Again, it has to have a bell-shaped distribution. And they're saying that the mean is $119 and the standard deviation is 22. Approximately what percentage of the electric bills are greater than 97? 22, we're trying to go lower, so we have to take 119 and subtract 22. When we take 119 and subtract 22, you get the 97. What you need to remember, if you split that 68 in half, right, you got what? 34% and 34%, right? To give you that 68%, that full 68%, 34% above and 34% below. Same thing with 95, 47.5% above and 47.5% below. All right, how do you get that? Just divided into two. Same thing with 99.7, but you get the point. But the issue is that 68% of your data lies between -1 and 1, or 95% of your data lies between -2 and 2. However, if you're just looking at a portion of it, 34, if you're talking about 68%, 34% of it lies above with that one standard deviation and 34% lies below. If you're taking them together, the total is 68%. But remember, that's an above and a below thing. Why did I mention that? Because this problem is only talking about below. If you take a look at the previous problem, it said between 24,100 and 26,700. So that's going to be 68% between that one standard deviation. This one is asking approximately what percentage of your electric bill is greater than 97. So we know that 97 is down here, right? So that's one standard deviation below. So that's going to be that one standard deviation below is going to be 34%, right? That's 34%. And they're asking what approximate is greater than that. So from here, but here on. So what's on this side? Well, since this is the median, right? 50% is above and 50% is below. That's 50%. We know this is 34%. And the rest of the percent is 50%. So that's going to be 34% plus 50%. That's going to be 84% of it. So approximately what percentage of the electric bills are greater than $97? 84% of the electric bills are greater than $97. Let's recap that. We know the mean breaks our stuff up into 50-50. Half of your data above, half of the data below. So we know that the above part of the data gives us 50% of the data. We know that since this is one standard deviation down, 68% lies between 1 and -1. Half of that, 34%, lies below that mean. So 34% plus 50% is going to give you 84%. That's how you work that one. We discussed the empirical rule. We discussed measures of dispersion, standard deviation, variance. We did some problems on standard deviation, variance, and the empirical rule. We had a matcha. We had some fun up in here. So of course, with all that fun, click like, subscribe, comment, do all of that stuff because I need to get to 220 and you need to see my next statistical banger. This is Professor Sampson from PS I Love Math.